I can't. So we have t squared in our denominator, right, Ben? And so the t squared is the problem y.
0 squared is 0.
0 squared is 0. So that's our problem. So right now, our issue is this t squared. What if we wrote it as a t and a t and canceled off one of the t's? Would we be good? No, we plug our 0 in, we still have problems, right? So that whole t squared needs to go away. Now, in grade 11, we learned something that caused radicals to go away. Now, in the numerator, currently, we have a binomial. We have two terms. Binomials are connected by plus or minus signs. They're basically sewn together. So, in rationals in grade 11, you were taught that if you had like an x up here and an x plus 2 down here, you couldn't cancel them off. You can only cancel a binomial for a binomial and a monomial for a monomial and a trinomial for a trinomial, so 1, 2, and 3 terms. So this is a monomial, and this is a binomial. We agree? So the only way the x plus 2 is going away is if you can get an x plus 2 in the numerator, and the only way the x is going away is if you have some sort of monomial. So if you had like x to the 4, then we would be able to cancel off one of these and make it be an x3 for that, because it's a monomial for a monomial. We agree? Why am I talking about this? Well, t squared is a monomial. We agree? And I need to get a monomial to cancel off. My numerator currently is a binomial. It's the square root of t squared plus 9, that's one term, minus 3. It's a binomial. The only way it can cancel off is if it's a binomial. So the way it's sitting currently, we're not getting that t squared to cancel. But in grade 11, we were taught to rationalize the denominator. We, in calculus, mainly don't have to rationalize denominators anymore. What does that mean? That means if your denominator is like square root 3, you can leave it. Okay? But we were taught rationalizing a denominator for a reason. The reason why you rationalized was so that you got the radicals to go away. The radical symbols went away. So for example, if we had, in grade 11, 3 over square root x plus 6, what would I have to multiply by to get that denominator to rationalize? Anyone remember? Square root x minus 6. Remember what that's called? The conjugate. Now guys, paying attention. Do you see how the top is different? In calculus, we'll leave them be that way, and I'll explain why. But the bottom, why do conjugates get rid of a radical? Well, let's talk about it, because we need to understand why we do what we do. So that when I give you something random, you can say, okay, maybe I need the t squared to go away. I need to get a t squared or a t cubed or t4 in the numerator so it can cancel off. I currently have a radical binomial. What could I do? Well, the reason why these go away is square root of x times square root of x is square root of x squared, which is just x, right? Two radicals that you multiply that are the same get you the same answer. So this denominator would be x. And then the reason why you multiply by the conjugate is the exact same binomial, opposite sign in the middle. The reason why you do that is it gets you, well, if I multiply root x times negative 6, I get negative 6 root x. And I told you the reason why we multiply by conjugates is to get rid of a radical. And then I give you a radical. So that sounds a little wrong. But when we do this one, 6 times root x, we get plus 6 root x. So that's why we use opposite signs, because those opposite signs actually make those two with radicals cancel. So that's why the conjugate is the opposite sign, right? Remember, we have to understand math, not memorize. We understand why we can't make mistakes, because we just know why we're doing what we're doing. And then 6 times negative 6 is negative 36, and I got the radical to get out of my life. You agree? So, I know that the t squared is my issue. And I need to somehow get a t squared or a t cubed or a t4 or something in my numerator so it cancels off and my issue's gone. The only idea I have here that I could possibly do, and what I always do is rewrite the question. I never work my math out of the typed question. People are like, I ran out of room because you put the question in the middle of the page. You shouldn't be working off the question. So you should be starting on the far left. So we're not always multiplying by the conjugate of the denominator. Sometimes it's the numerator. So for this one, I am going to multiply by square root t squared plus 9 plus 3. And when I do the top, I have to do the bottom. Why do we do that? Remember, understanding rather than memorizing? Why do we have to do something to the top and the bottom? It's as if you're multiplying by 1 then. Because if I do 4 over 4, that's 1. 8 over 8, that's 1, right? If I do root t squared, or the square root of t squared plus 9 plus 3 over that, I'm multiplying by 1. And multiplying by 1 doesn't change anything, right? But if I did it to just the top or the bottom, I'm not multiplying by 1. Now, guys, what is my problem child here? The t squared. So this is where people get messed up. They'll distribute the t squared into this conjugate because we have drilled distribution so hard into your guys' brains. You just like, must distribute. Like that's where you are. But I need this t squared to get out of my life. If I distribute it into that t squared plus 9 plus 3, I'm embedding it in more stuff. And now it's getting messy and I'm not going to get it to go away. So we do not distribute these. Now, I don't want you to memorize that we don't distribute those. I want you to understand why we don't distribute those. We don't distribute them because we want this t squared to cancel off. And if I put it in there, then it's embedded and I won't get it to cancel. Okay? So the top will distribute. So let's try that out. We get an equal sign because this limit is equal to the next one, is equal to the next one, and we always run a left-hand side down an expression. So we get the limit as t goes to 0. And we get root t squared plus 9 times root t squared plus 9, which just gets us to t squared plus 9. And then we get minus 3 or plus 3, whichever one we want, root t squared plus 9, minus 3 root t squared plus 9, canceling, and then minus 9, all over t squared. And the people who can't do these questions are the ones that distribute this because they don't understand that we need that t squared to cancel off. So I don't want to distribute those two. We agree? All right, the plus 9 and minus 9 cancel, and what am I left with on the top? Oh, a t squared, and what do I need to cancel off? Oh, a t squared. All right, good talking to you. So what are we left with in the numerator when it completely cancels off? A 1. Ooh, don't even know what I just did. Go away. All right, so that's gone, that's gone. I'm left with 1s. So the moment I cross that off, what can I do? Put in that 0. I can substitute in because I got rid of the issue. Yes? So we get 0 squared plus 9 plus 3, which is 1 over 3 plus 3, which is 6. So from the left and the right of 0 on this wonky graph, it's approaching 1/6. Because the square root of 9 is 3 plus 3, which is 6. Yes? Do you all agree? Okay. So I want to show that the absolute value of x gets me 0. Well, we can even look at a graph. So the absolute value x graph, so this is just an equation, right? It's y equals or absolute value of x, which you talked about in grade 11. If I want to, I can just make a t-table for it. So I can go x, and then my y equals just the absolute value of x. So say I have 0, this is going to be the absolute value of 0, which is 0. If I have 1, the absolute value of 1 is 1. If I have negative 1, what's the absolute value of negative 1? 1. And then 2 will be 2, and then that negative 2 will be 2. And so we end up getting this graph that's like this, 0, 0, 1 and negative 1 and 1, 2 and 2, negative 2 and 2. And we get this V. Do we agree? So how we prove that a limit exists is to prove that from the left and the right you reach the same value. Yes? Some people will say, well, the limit as x approaches 0 is 0. Done. That's not how you actually prove it by a written response. You have to show from the left and the right it approaches that value. So we go the limit as x approaches 0 from the left of absolute value of x equals 0. The limit as x approaches 0 from the right of absolute value of x equals 0. So from the left I'm approaching 0, from the right I'm approaching 0. then I say therefore, 3 dots in a triangle, the limit as x approaches 0 of the absolute value of x equals 0. So you don't always have to show it algebraically unless it's said algebraically. You can show it with a graph. You can show it with a table, right? From the left and the right what it's approaching. If you wanted to, you could go, oh, I want to get closer. So I could go 0.0000001 is 0.0000001. Negative 0.5 and 1 is 0.0000001. So through a table, you can actually show that it's getting closer to 0, right? You don't have to always show algebraically unless I say algebraically. Sometimes I do. Like the previous question I would have asked you some algebraically. All right. Example 8, we have a piecewise function. You've never seen so many piecewise functions in your life until like this last week. So this says if f of x equals square root x minus 4, if x is greater than 0. This is from the what? X is greater than 0. Is it from the right or from the left? It's going to be right. And then less than 0 is going to be from the left. So that's where I can get my two limits from, correct? So let's fill it in. So if I go the limit as x approaches 4 from the left of f of x, that's great, but I now have to fill in what the heck f of x is, because f of x actually has two equations. One is just if it's from the left, and one is just if it's from the right. So I now go the limit as x approaches 4 from the left. Which equation do I use? Top or the bottom? Bottom, because it's x is less than 4. That's from the left. Greater than is from the right. Because if you're less than 4, that's where it's going to come in from the left. If you're greater than 4, that's where it's going to come in from the right. So we need the less than one. So it's going to be 8 minus 2x. Do I have to do anything to it in order to put the 4 in, or can I just substitute the 4 in? I can just substitute the 4 in. There is no issues. Correct? So when I substitute the 4 in, I get 8 minus 2 times 4, which is 0. And then people are like, that's a problem. Can something equal 0? Yeah. Can something divide? Can you put a 0 in your denominator? No, but your answer can be a 0. 0 happens all the time. So that's fine. So now I need the limit from the right. And if they're the same, then the limit at 4 is that value. So I put the limit as x approaches 4 from the right of f of x, but now I need to figure out which of those is f of x. So greater than root x minus 4. I still have the limit sitting there because I haven't substituted in. The moment I substitute the 4 in, the limit goes away. I get 4 minus 4 with the square root over top, which is the square root of 0, which is 0. So when they're both equal to 0, what can I say? Yeah. Therefore, the limit as x approaches 4 of f of x equals 0, and it exists. It asks if it exists. I do not believe the brain matter right now is at the point of squeeze theorem. We will come back to squeeze theorem. It makes people not the happiest campers. So we're going to leave squeeze theorem. We're going to come back to it. I promise. Just not at this moment. It makes people cringe a little. So we're going to get ourselves into a good spot before we do the squeeze. So example 9 is squeeze theorem. I'm going to have you do the homework, but I would like you to work on it. There is a question, I think it might be 36, that's on squeeze theorem. You can't do it because I haven't taught it. So I want you guys to work on this, and I want you to work on it right now so that when you're doing the algebraic one and maybe you're stuck, you're like, oh, I know x minus 2 is my problem, but I just don't know how to get my problem solved go away. I can help you. Okay? So work it.